Okay, looking at compositions of functions. Don't make this problem more difficult than it is. It says h of n is n plus 4. They want us to find h of 8. So all we would do is replace n with 8. So h of 8 is 8 plus 4, which is 12. That's your solution. Don't make it any more complicated than that. 20. They give us an f of x. They give us a g of x, and they say find that. Don't make this confusing. Look what it says, g plus f. Take g, add f. 4x plus 5 plus negative 3x cubed plus 2x squared. Combine like terms. Well, there are no like terms in this problem. So the best we can do is put it in standard form. And that's your solution. Okay? 21 is going to follow the same pattern. It says find g minus f of a. Well, take g, subtract f. So negative 3a plus 3 minus parentheses 2a minus 3. Okay? That parentheses is going to be important. I used it over here. Use it over here. Distribute the negative. Negative 3a plus 3 minus 2a plus 3. Combine like terms. Negative 3a, negative 2a. It's negative 5a. 3 plus 3, 6. Okay, so look on the inside of the parentheses. It will tell you what you're trying to find every time. Okay, so this is number 22. Look on the inside of the parentheses. It says take g, multiply it by f. So I take g, and I multiply it by f. Do box method. Multiply it. 4x squared, 16x, 5x, 20. Combine like terms. And that's your solution. Okay. The last one's a little bit trickier, but it's still not too bad. So, there's two different ways of doing this problem. The way that we're going to do it is we're going to subtract f minus g, and then we're going to plug in 4. Alright, f minus g, then plug in 4. So, f is 3n plus 5 minus g, n squared plus n. Distribute the negative. 3n plus 5 minus n squared minus n. Combine like terms. Negative n squared, 2n and 5. Okay, now we're not done. We have to do something with this 4. Take the 4, plug it in for the ends. Negative 4 squared plus 2 times 4 plus 5. Be very careful, you notice where the negative's located. It is on the outside. We are not squaring the negative. So this makes this negative 16 plus 8 plus 5, which makes my final answer negative 3. Okay, so subtract the functions and then plug in 4. This problem looks really complicated, but it's actually quadratic techniques. If you don't remember quadratic techniques, go back and look at it. But the middle term is half the first term, and it's 3 terms. So we're going to factor it just like we would a quadratic. Multiplies to give 10, adds to give 7. That's 5 and 2. But instead of putting an x, we're going to use that term right there. So we're going to do x squared plus 5 and x squared plus 2. And that's actually, as far as factors as you can get the problem, that's your solution. Okay? I'm actually rereading the directions on number 24. What it says is find all roots. So we set these two equal to 0. So we take those two things, x squared plus 5 equals 0, x squared plus 2 equals 0, and we solve it. X squared equals negative 5. Take the square root of both sides. X equals, every time we take a square root, we do plus or minus. The negative underneath becomes an I, so it's I squared to 5. Over here, x squared equals negative 2. Take the square root. X equals plus or minus I squared to 2. Those are actually all the roots, or also known as solutions. Okay? On number 25, they ask us to find all rational roots. Well, guys, this is P over Q. Okay, P over Q. P, everything that multiplies to give us the constant term. So in this case, 2 and 1. Q, everything that multiplies to give the leading coefficient. In this case, it's just 1. So P over Q is really simple. Plus or minus 2 divided by 1 is 2. 1 divided by 1 is just 1. So that's all of my possible rational zeros. P over Q. All right, looking at number 26. I'm actually going to do this one on the paper. You need to factor this. So this is going to be x squared times x minus 3 because they both have an x squared in them. And then solve it. So setting this equal to 0, we get x equals 0. Setting that equal to 0, we get x equals 3. These are x-intercepts, 0 and 3. But if you think back to graphing polynomials, you remember x squared, this is a multiplicity right here. So that means we have 2 zeros right here. And then this is a single solution, so it means it's going to cross through. Now, also, leading coefficient. The degree is odd, so the end behavior is going to be different. So one of them's going to go up, one of them's going to go down. Leading coefficient is positive, so that means my end behavior looks like that. So we know it's going to come up, bounce off this, come down, and curl back up. Now it's going to look something like that, but this is a multiple choice test. Pick the one that looks closest to that, but you know it's going to cross through here, bounce off there, and this is what the end behavior is going to look like. On number 27, I don't have a graphing calculator on me, but the best thing to do is to type it into y equals, graph the thing, look at it, pick the picture that matches up with it the most. Okay, so I'm not going to work through 27, take a little bit too long, but that's the way that you would work that problem out. 28. Zoom in for you just a little bit so you can see the problem a little bit better. Okay. Now what we're going to do, it says maximum number of turns. Each teacher teaches this quite a little bit differently. The way that I do it, look at your highest exponent. That means that we're going to have 3 directions. Okay. Now I know some teachers teach it by the turns. I teach it by the directions. We know it's going to go in 3 directions. And now type it into a graphing calculator, graph it from there. But the main thing I wanted you to get out of here is that this thing is going to have 3 directions. Number 29 and 30 will be the last 2 that I do on this. Number 29, notice they all have an x in common. So we pull an x out. So that means this is x squared, 7x, and 10. Now this is an extremely easy problem. X games. Multiplies to give 10, adds to give 7. That's 5 and 2. So we have x times x plus 5 times x plus 2. It said find all zeros. So that means set them equal to 0 and solve. X equals 0, negative 5, and negative 2. Okay, so those are all my zeros for this problem. Number 30, even easier. They gave it to us in the form that we need it in. Set them equal to 0, x equals 0, x plus 4 equals 0, x minus 3 equals 0. Now you solve these. So x equals 0, subtract the 4, negative 4, add the 3, positive 3. There you go. All right, so that's the end of all the problems on this video. I'll pick up with number 31 on the next one.